how many years do you think it's going to be, even if you had to make a rough guess, where it's going to be actually cheaper to make a 3D printed house than one with traditional construction? Building on Mars and the unique circumstances that we have in that space, quite literally. And so there was something in there that really was interesting to me that I think a lot of people in 3D printing, and especially in the construction of homes with this technology, haven't thought of entirely, and that is that gradient of materials that you discussed in your TED Talk. When you're putting in different aggregates and making a structure that kind of just gradually changes. I want to hear your thoughts on what is most effective currently that you've seen in this thought of that gradient material, along with things that you think might be possible, let's say within the next 5 years. I'd love to hear your perspective.
Okay. So the idea of these gradient materials, functionally graded as we call them, is that we can actually design the material the same way we design building parts and design buildings and design cities. So basically, the framework behind the design of functionally graded material is the same that I use for designing customized houses. It's basically the same structure. The idea here is actually to increase the performance, to optimize the performance of the building part for its intended use. So what we can do, so we basically, if you think of something like concrete, which is a composite material, so you have the binder and they have aggregates. And the idea in this case is to replace part of the aggregates, the traditional aggregates like sand river, by other materials like cork. As you know, cork is very abundant in Southern Europe. It's used in as many different applications. They even make clothing out of cork. And there's cork granules, so the idea is to replace part of the sand aggregates with cork. And by changing the percentage of cork, you obtain materials with different properties. For instance, if you want the material to be stronger, you decrease the amount of cork. If you want the material to have better insulation properties, you increase the amount of cork. So the idea is that when you're designing a building part, it's optimized. So you can actually, in each point in space, you have the material with the exact gradient to have a maximum performance on that point. So that's the basic idea.
No, and that's an interesting, idea. Maybe if there was a double wall, and I'm just thinking this as you're saying it, so it might not be a comprehensive thought, but if we're thinking about...
We no longer have double walls, so you have a functionally graded wall.
Oh, okay.
So instead of, and that's the idea. So if you think of a wall is actually, a set of different building elements, like the coating, the insulation, the structure, the inner structure, the outer structure, the cladding. So by using functionally graded materials, you can actually have just one element that's printed, customized for that particular position in the building.
And so I want to
simplify the trade, simplify construction, make it cheaper and easier, and with the optimized performance.
And so what has been the most effective use of this mix that you've seen out there with a gradient? Is it cork? And can you give some other examples of materials that you think either have promise, they might work out, or that you've seen really be effective?
So we have already experimented with expanded clay. That's another possible material. And I have a colleague here at Penn State who's actually experimenting with glass. So we have done some work together in the transition between opaque concrete and transparent glass, so that you would eliminate, for instance, the window mullions. Again, simplifying construction, decrease the probability of some air leaks or water leaks. So in basically getting a part that works better. And for Mars, it was ideal to have something like this for harsh environments, actually.
Well, I even think of one of our partners, Greg, who does construction, and the thought of just putting a roof on a house. You put a skylight on there. Do you need to stare up into the sky all the time? No, you're looking for that ambient light. So if you can get some translucent properties, it's a very interesting value proposition for how we could be creative in combining the material science, the construction, and then also needs to save energy, because obviously if more light is coming through that translucent material, you need to use electricity less. There could be some thoughts there that are very interesting.
So we did some study with the cork, for instance. we were able to save about between 30 and 50% energy over a period of 1 year just by using the functionally graded materials. So that's a huge impact on energy performance as well.
No, that makes a ton of sense. And so my next question relates to where this technology was kind of applied, at least with this project in partnership with NASA, and that's on Mars and in space. You know, I'm someone who gives speeches for charity in many regards, and so as someone in that space, there's a JFK moon speech that I think about constantly because it's just extremely well written, and it was given at Rice University. But in that speech, JFK, as the President of the United States, he's trying to defend this thought of investing into this technology and going to the moon. When people here on planet Earth are hungry, are sick, or dying, need vaccines, all kinds of challenges. You know, people are like, why are we investing all this money in going to space? And so I want to ask you this question as it relates to that Mars project that you work with. You know, why do projects like this, specifically with universities and with NASA, why is it worth our investment, and how does it challenge us to you know, reach in ways that without that impetus we just wouldn't even attempt?
So I know I'm a believer. So I think, you know, it's impossible to stop human curiosity. So, and part of the idea of going to a place like Mars or going to other planets is actually to satisfy our curiosity. But obviously there are advantages. So there are immediate advantages and there are long-term advantages. The immediate advantage is, you know, the effort that you place in developing a technology to do something on Mars, or either going to Mars or build on Mars. You know, the technology you developed can be used on Earth. Like, you know, for us, it worked very well. Thanks to our participation in the NASA competition, we were able to leverage our research. We were able to have access to funding, enough funding to develop the technology. And now we have a working lab. We can actually focus on our attention on designing houses for Earth, for low-income people, and so on. So, you know, that's an example. So that's what I call, you know, immediate reward. But obviously there are long-term rewards. I think, you know, going to Mars has other advantages. You know, you might be able to explore other planets. And I understand the concerns, the ethical concerns that some people have. But I think at the end of the day, I think it's a good investment. It will pay back.
Yeah, and we need to consider all of the benefits that actually did come from landing on the moon, right? You know, there's a lot of technologies that were advanced that we use today, even as consumers. Even think of concepts like GPS. You have to box yourself into a challenge sometimes in order to, you know, push yourself towards a goal that seems impossible, but like you said, sometimes has a lot of benefits today. And so one of the things that I saw in your TEDx talk was, you know, very unique to Mars, but I think speaks to what you just said. It's something that helps us understand conditions today, which is, as I was watching this animation play on the setup of the 3D printer, right, before construction begins, it created a dome. Right, it created more of a laboratory-like condition. Obviously, still rough, but it you know, changing the wind. I don't know if climate control was a part of it at all, but you can't mess with that print. And that happens here in the United States and across the world with 3D printed construction as well. In fact, my brother today is down in Florida watching you know, a 3D printed construction project go off, and in Florida today it reached over 90 degrees. You could see the concrete quality change and wave in a way that it was just not productive. And so I wanted to get your thoughts and perspectives on that dome. Should we be focusing on that, or do you think applied material science is going to make it so things like that aren't needed? Your perspective.
So I think we need to work on different fronts. So we need to work on the development of the materials. We need to work on the development of the printing system, and we need to work on the development of this design. You know, the reinforcement, the structural principles, the shape, the form, and so on. So it's hard to tell what the future is going to be. So we might have some cases in which we will need that dome to enclose the printing space, or the materials might evolve enough to, you know, to avoid the need of that dome. I don't know. You know, it depends on the environment, depends on the technology evolves. Right now, we are designing houses for Alaska. It's also permafrost region. It's a very harsh environment. Using what we learned from the NASA competitions, it's again an immediate application of the technology developed for a situation on Earth. And we are not going to use the dome to enclose the printing space, although the temperatures in some cases, are similar to Mars, -50°C, for instance. That you can reach it. That's exactly what the temperatures that we consider on Mars, because we're building on the close to the equator, or Mars equator. It was between -50 and +21°C. So it's very similar to the situation we have in Alaska.
Yeah, no, that makes a lot of sense, and it may just be a combination, right? Maybe the material advances to a certain degree, so it means that you don't need to have as much of that climate control feel, or it limits the use of those domes to some degree. But it's very interesting. I heard that with the Cobod machine that they're at the point where with the materials they're using, between 50 degrees and 90 degrees is the range. Now here in the state of Ohio and even in Pennsylvania where you're at, it's going to serve us a good amount of time, but it also gets pretty cold, and you'd like to build in those months as well. So we'll see where that goes. My next question I wanted to ask is about the thought of deformation. We spoke to one of your students, Nigar, and she was talking about her thesis on deformation. And, myself coming from a charity space, my brother coming from traditional construction, we're trying to still get our minds around the importance of this seemingly small, element of the construction process. But is so important. I wanted to ask you, how would you explain the importance of deformation in 3D printed construction to a middle schooler or to, I don't know, 36-year-old me? I would love to hear how that plays out, why it's so important.
Yeah, the kids like to play with that Play-Doh, right? And they make construction out of Play-Doh. So if they try to pile something, at some point it might collapse, because at the bottom, the layers at the bottom can no longer withstand the load of the top layers. And so when we are printing, the material deforms because it needs to flow well. So in order for it to flow well, it does not harden immediately once it's extruded. So there are two possibilities. Either we add something to the material to make it right before it's extruded, so that it hardens immediately, after being extruded. Or you can take into account material deformation, and that's what we are doing. Why is it important? So if you take into account deformation, you can plan for it. You can avoid collapse, premature collapse. You can, guarantee that we'll end up with an accurate shape. For instance, if you are trying to print a cylinder, and if you design a cylinder and print the cylinder, you'll end up with a cone, because the layers at the top will deform under the weight of the subsequent layers. So we end up with a shape like this. So if you actually design an inverted cone, when it's printed, it will be a cone. So that's an example. But also, to guarantee accuracy, you want a shape with a certain dimensions. So if you take material deformation into account, you can actually get the right shape and avoid collapse at the bottom.
Yeah, and in the similar vein of that question, when I was talking to the dean of, I believe, the University of Technology at Eindhoven. Yeah, Eindhoven University of Technology, Theo Salat over there. He gave the Digital Concrete 2020 keynote presentation. He talked about three things that he thought were really going to make a difference. One of them was the pump, right? Right now we have pumps that aren't really designed for this application, and as that advances, so will the ability to build more consistency with less labor, et cetera. He also talked about AI, right? Artificial intelligence helping, balance all of these factors in a way that doesn't take human intervention and do things that even humans can't really do in such real time. But I wanted to ask about the third thing he mentioned, which is the nozzle, right? He said, as the nozzle advances in technology and changes, that's going to make a big difference. Now, I didn't have enough time to go into all the elements with Theo, and that's why I'd love to ask you this question about how important the nozzle is, because I've got a printer, right in the other room, like a Prusa Mini Plus, and I'm thinking, well, I don't know, it's just a nozzle, it just comes out. It doesn't dawn on me. The pump made sense, the AI made sense, but talk to me about a little bit of why you think the nozzle is important, the differences in how that nozzle really changes a 3D printer when it comes to concrete construction.
So actually the AI and the nozzle are linked. So, and we are actually developing what we call a smart nozzle at the moment. So it's very important. So the smart nozzle can have many different functions. One of them is to compensate for material deformation. And that's, for instance, the work that we described that my student is doing is crucial in this regard, because it can react in real time. So you can change the speed of extrusion, in real time, to adjust and to compensate for material deformation. So our first step was actually, to do what I've just described, compensate in terms of the shape that you design. But if you use sensors and you are able to, check, for instance, a change in the extrusion rates or a change in the amount of water, you can compensate in real time for that and take that into account. So a smart nozzle is actually very, very important.
Yeah,
and AI is used in different ways. So, today people, when they talk about AI, they think they're thinking about machine learning, but actually AI has many different paradigms. Machine learning is just one of them. So we use optimization a lot to find, the best design configuration on different scales. But you also use machine learning, and and machine learning can be used together with a smart nozzle in the compensation process, compensate for the material deformation in real time.
That makes a lot of sense. I think AI is a huge industry. I actually worked at an enterprise software company for 5 years in market research and competitive intelligence, and AI has a lot of different applications, but I think that's going to play a huge role in that pump as well, and making sure that you have consistency, that you're factoring for the temperature and things like that. But it seems like all of these things are going to play together. So the break-even point for this technology, as we think about creating housing for those in poverty, right now we're hearing numbers from folks saying it's 140% more than a traditional house. It's 300% more of the cost than a traditional house, because we're getting through some of these learning curves that every industry has to go through. So my question for you is, how many years do you think it's going to be, even if you had to make a rough guess, where it's going to be actually cheaper to make a 3D printed house than one with traditional construction?
So I think you need to look at the problem from different perspectives. The cost is not just the main issue. You can right now you can use 3D printing applications with in situations that's more advantageous to use this technology than traditional technology. Like, for instance, what we are doing for Alaska. We are actually enabling something that was not possible before. And that's not a matter of cost. It's a matter of being able to do it or not doing it. We also, when we were applying for a patent, our lawyer said, this is really good. The first application is not for low-income housing, because that's what we were talking about to them. They say, the initial application should be for very expensive houses, because they are already expensive, okay? And what you are going to do is to do something that's unique, but probably at the same price. So in this case, it's already possible and advisable to use 3D printing. In the long term, I think 3D printing will be used for printing low-income housing. Maybe it will take 5 to 10 years. Maybe 5 is enough. I've been working with a foundation to design houses for India, and they see the advantage and the benefits of using 3D printing technology. So I say, because we are still developing the technology, obviously it's more expensive now, because we have to pay for all the development. Once it's developed, then you start using it, you increase the number of things that we are producing, and then, it's economies of scale, the cost will come down.
Absolutely. And in that thought of helping those in other countries, we got to kind of keep in context the American experience. For me, just growing up in the United States, Obviously, anybody seeing poverty should be disturbed by it, but what poverty means in the United States and what it means in India are two entirely different things, obviously. And part of that is wages, the economy structure, a lot of different things. But 3D printed construction is most advantageous economically in countries where labor costs are high, right? In certain European countries, in the United States, right? Because you're comparing something that's high, and the higher it is, the easier it is to be underneath that cost. But in India, some other countries where labor costs might be lower, it might take longer for 3D printing construction to make sense. But with your experience with this foundation, I would love to hear what they're thinking, what you're thinking in that context.
Right. So you are right. On one hand, it's more expensive, to build here than in India, and therefore it's, it makes more sense to use the technology in a rich country like this than in a country that is not at the same level of economic development. But on the other hand, so these countries have a huge need for housing. So you actually need to produce millions and millions of houses. Whereas in Europe, you don't need that because the population basically is stagnant, or it's even decreasing in some countries. So it makes a lot of sense to invest in the use of the technology in, let's call them, developing countries, because they have a huge demand for housing. The population is growing at a very fast pace. People are going to the cities, the fast urbanization process. And therefore, yes, the labor costs are lower, but the demand is much bigger.
Yeah, I think another factor is the construction quality as well, right? If you don't have the same technology in that developing country, the same pipeline of skilled labor and building standards, things like that, you have variables that are affecting, okay, let's say you can build a house for cheaper, but it won't last for as long, it's not as safe, and a 3D printer can help with those thoughts. My next question is, what questions should I be asking you? Meaning, well, what is that one thing that people in this space should be talking about more, should be more interested about, or something that you're working on that is
well, as an architect, obviously I'm curious about the impact of the technology on architecture, how it's going to change architecture. Now, I like to give this example. When we start designing the first cars, they actually look like, carriages, right? And it took some time, it took a few decades for the cars to start looking like cars, not like carriages. And I think it's going to be the same here. So we are still learning. So obviously we are getting inspiration from vernacular and traditional architecture. So following the same principles that have been followed for, centuries and sometimes even more than that. But I'm curious to see in the future, with use of this technology, AI and so on, I think, the architecture is going to start to look completely different. And that's what I'm interested in. I mean, one of the many things, but I have a particular interest in that.
That makes sense, because I think the average American consumer, the average person just watching the Today Show, right? They see 3D printed houses, $10,000. They see this catchy line or whatever, and they're obsessed at the machine. It's almost hypnotic, right? It's like it moves very smoothly, and it's almost just fun to watch. But people are so focused on the machine, the hardware, the fact that the printer exists, they forget that that file, which is really what you're talking about in some way, that the architecture, that file and design, the innovation in that idea is completely untapped.
One simple aspect, but I think it's a very good example of what the technology allows us to do. So we are not bound by simple shapes. It costs the same to design and build simple shapes or complex shapes. On the top of that, we can actually start playing with color and texture. So you can actually create, not just the different shapes, but also introduce textures and colors and different coloring. So in the future, you can change the color of concrete by adding different color mixtures to the concrete. And you can play with textures. You can actually create very interesting textures. So I'm first thinking about the traditional vernacular housing in some parts of Africa. We have these beautiful textures with different colors and so on. We can do that now, so it can completely change how a house looks like. Obviously, there are some cultural issues. People will not like to transition to these houses immediately. But over time, so this is something important to stress. It's not just a technology, it's people as well. Okay. You might have the ability to do something, but if it looks very strange because it's so different from what I used to do, maybe people would not like to live there because they want to fit in, they want to blend in. But over time, they will become more open to change and start enjoying and appreciating the new forms, the new shapes, the new colors, the new textures. So so that the things need to evolve in parallel, the technology and people, people's expectations and needs and so on.
Makes a lot of sense. It takes a while for us to get used to a lot of new technology that's coming out. And when you talk about what the average American spends 30% of their income on, right? And what they see as a long-term investment for their retirement even, they want to make safe bets, right? It's even if somebody wants a red house, they don't paint it red because they're like, well, that's not going to sell well. That's going to make me stand out in a way. Even if in their heart they want something different. But one day when we print a neighborhood of 100 houses, and they can all be unique in still a uniform way, but take advantage of some of this design and technology. It'll be interesting to see what neighborhoods, look like. Because right now, neighborhoods generally just means bigger house or smaller house. The style of house, it doesn't change all that dramatically, but now it can.
So something that the technology also allows us to do today is actually to let people have a glimpse of how the house is going to look like. Before, only an architect or an engineer could understand drawings, right? Lay people would not be able to understand. But right now we can, we have, three-dimensional renderings. We have even VR, virtual reality. Let me give an example. A few years ago, I did a study on a favela in Rio. And at the end, the students went there and actually took a portable VR system to show the people who lived in the favela how they could transform their environment if they were following, so students basically was making a presentation in VR. And that's something that we forget, the technology also allows us to do this today. So people can visit the houses and can even, enter the house and start making changes in a virtual environment to change and, adjust the house to your needs and desires and so on. That's another layer.
I love that idea. I've got a Quest 2, an Oculus Quest 2 in the other room, so I can see how these things could definitely pair together. But I think in order for this industry to really sing, to really grow as it needs to, it runs into the same problem that traditional construction is running into, which is appropriately skilled and educated labor, right? We've got to get kids, literally children, interested in this in middle school and elementary school now, so that when we get to this break-even point of 3D printing, when things advance even further beyond that, there are actually skilled folks to design in this new way that was never thought of before. From your experience as an educator and with Penn State, how do you see the education space in this area growing, and what are you excited to see develop?
Let me give an example. I grew up playing with Legos. Okay, as I said in my TED talk, it has a huge influence on how I approach architecture. So it's modular, and you can do many different things by combining different modules with different colors, shapes, sizes, and so on. But look, now the paradigm is 3D printing. So if kids start to play with a small 3D printer and they're not that expensive anymore, can you imagine what they can do? How is the impact it's going to have on their education, on the things that we'll be able to do in the future? That's something that makes me very, very excited.
I love that idea. We've been thinking about a phased business model approach for even our own organization, realizing that you're not going to, print houses for half the cost today. That's just simply not even close to possible. But as we are, trying different materials and using the printer, why not invite high schools and colleges, on site and create educational experiences? I mean, we're just printing these things anyway, whether it's a planner for,
Right.
a tree to go in front of a mall or some decorative sign or things like that to hone in the technology and our design skills. Why not get education involved? I think that could be a huge benefit to STEM schools, whether at a university level or certainly a high school level.
Yeah, I think that's a very good point. For instance, if you go to a country like Brazil, there is such a huge demand for housing, and people live in favelas. I mean, you should teach students in school how to build a house. because they will need to know it instead of feeding them with information that's not as important or it's secondary. You actually should teach something very practical, and that's actually something that I like about the education in the US. It's already very practical. My daughter was in school here in primary school, and I love the way for instance math was taught, because they was taught from the perspective of someone who needs to use it on a daily basis, and I think that's very, very interesting. So we can we can follow a similar approach with this kind of technology. Show them how 3D printing can help on in their lives on a daily basis, and there are many different applications.
Yeah. And my final question is, anything coming from Penn State, from your work here soon, whether it's a presentation, whether it's a new project, would love to hear about what's next for you.
So as I said, we are designing houses for Alaska, and I'm very excited about this project because it's an opportunity to continue developing the technology, but also do something that's it's real, it's going to be there. So I'm very excited about this. I'm also very excited with the work we are doing with this foundation on designing houses for India. So we are at that stage that they're very close to actually doing something in practice, so have a real impact, and I'm very excited about that. Not just research, not just intellectual challenge and pleasure, but also the ability to finally seeing it.
Yes, I think that's what it takes to have vision, especially in this space. You've got to have a weird amount of patience, right? You've worked so long to create this technology, this knowledge, this understanding, and now with all that patience, you're getting to this point where those practical projects are really taking shape. My charity that I work for does some programming with Bethel, Alaska, right? So this is an Inuit tribe, and poverty is extremely high. It was very hard hit by COVID as well. A number of different challenges. You have to take a series of planes to get to this location. And so I've always wanted to visit Alaska, and whenever this project gets started, I would love to hear about its timing.
Hopefully we'll be there next year building,
yes.
A year from now. That's what we'll be doing. So Alaska is interesting because, their traditional houses already look different. So actually, when we presented the design, they didn't find it strange. If you were showing it to someone in Pennsylvania, for instance, say, "Oh, this looks very different," but for them, it actually looked very similar. Very, something familiar, very familiar.
Can you describe what the structure kind of looks like? I mean, what elements of it are different?
Okay, so let me just say, I don't want to say too much because it's not completed yet. Say it's inspired in traditional vernacular shapes that follow the same structural principle. And it's designed in a way to actually isolate the interior, from the cold outside.
Well, that makes sense. Again, my brother down in Florida, watching this Cobod print happening in this 2-day workshop, just talking to the other 25 folks who are in the same program, kind of, assessing which printers they might buy or if they'd like to enter the space. And I just talked about like the waterproof properties of this and how it might be applied to seawalls, how it might be applied to areas where it's prone to flooding, or even the fact that the claim was the concrete could withstand 2,000 degrees Fahrenheit and could survive wildfires. To your point about Alaska, there are a lot of environmental conditions where literally living there is difficult, and part of that process is having the building to live there in, and so solving some unique challenges, again, that really are difficult to approach with traditional construction. Well, Jose, I really appreciate your time and your perspective.